Up, please help me welcome Saya Kill Chalika, Loveland McCarthy, Neil Patel, Dan Iyer, and Anwar Alba. Through hard work and dedication over the last 6 months, they are going to present us their app, the SkinSense app, a personal app to detect any part of your skin for skin cancer. So thank you all very much. Do we have to do it on? Does it work?
Yeah.
Oh,
Alright, so from William G. Enlow, we present to you the SkinSense app. Alright, so let me first introduce you to my team. My name is Saika Shalaka, and I was the team lead / project manager.
My name is Rosalind Eccles, and I'm the UI designer and planner.
My name is Kumar Calder, and I was the lead programmer that developed the application.
my name is Vinod Iyer, and I was the lead researcher.
And finally, Neil Patel, who couldn't be here today, was the videographer and editor for this project.
Let's start off with our inspiration. So on this slide is a picture of my grandmother. In 2021, she had an MOHS procedure to remove a squamous cell carcinoma. She was pretty lucky because she goes to the doctor frequently. She only had to have one layer of skin removed. But it made me wonder and concern the future of skin cancer risk in my family and in my community. And it made me wonder what we can do to increase the detectability in early stages.
So with that, we actually decided to understand skin cancer and how it works. So the first thing we realized was that skin cancer originates in melanocytes, which are the skin cells that produce pigment, which is responsible for melanin, which is responsible for the color in your skin. And so with that, we realized that skin cancer develops in the skin cell, and it starts with a mole or any other structure similar to that. It then spreads throughout the bloodstream and eventually enters things like your liver or your brain or other vital organs like that. Once it develops and goes all the way to your brain and your other organs like that, it's really hard to cure. And so early detection is extremely crucial. So that can be shown through the 5-year survival rate. If you see, stage 0, 1, and 2 have a survival rate of 98.4%. But if it's detected in stage 4, the survival rate goes down all the way to 22.5%.
Continuing, let's take a look at our community, which is Wake County. Wake County is the largest county in North Carolina by population, and due to that, and it being an urban area, it has high poverty rates. A lot of these people who live in poverty rates are either uninsured or on government insurance, and they aren't able to access specialists like dermatologists, like people who are insured are. So because of this, we want to increase accessibility.
But this issue isn't just for our community, it's a global thing. You can see that in 2020 alone, there were an additional 150,000 cases of diagnosed melanoma. And that number is likely far higher because of the undiagnosed patients. And even worse, the rate has been going up by 30% every single year with no signs of stopping. And this gets far worse because treatment costs in stage 1 are only $1,700. But when it's detected and treated in stage 4, this cost goes all the way up to $56,000, further emphasizing the need for early detection. So what's the solution? We decided to build an app that can detect any part on your skin from the comfort of your home, allowing you to have no reason not to check your skin.
The front of this application was programmed using React Native and Expo, both of which are JavaScript frameworks. And we also use React Navigation to create an elegant and user-friendly interface. The backend was primarily in Python, and the main part of the backend was the machine learning model that we created that's used to actually detect melanoma in different images that the user can input in our application.
Alright, so let's take a look at the app demo right here. Alright, so you're going to start off by seeing our logo, which is just loading the app, and then you see our name, and then you're going to get directed to the home screen of the app, where you can actually pick an image, and it's going to show you the probability of that image actually having melanoma. And so that was done using Python because of its popularity and accessibility for lower level devices. And so you saw that it instantly outputted a probability of 63%. And that was actually done without the use of the internet. And the model actually runs natively on the phone, which is a big thing for us because we wanted to be able to be as accessible as possible. And that was really important to not require an internet connection, as a lot of people don't have that luxury. This is also done using Google Colab because of its computing power and Jupyter Notebooks. Then you see our results page, which actually shows you what the results mean. Because for some people, you might not understand what 63% means. And so you see exactly what it means and what your next course of action should be for this. And this is actually done by reading a lot of research papers by a researcher without hiring. Additionally, all of this was used by building JavaScript, as Kumar just said. And we use that because it's cross-platform compatibility. You can release this on the App Store or Google Play Store, allowing you to reach as many people as possible. Then you see the log page where you can actually log every time you use this app. And then you can show that to your dermatologist or anyone else, or just track your progress if you want to see it. And on top of that, you see the info page, which has a lot of valuable information. And if you actually scroll down, there's a lot of links too for you to actually learn about the staff, how it works, and learn about melanoma in general. And this was all done by using Android App Studio, again for its cross-platform compatibility, and also emulator, which you're actually watching the app on the emulator right now. So it works really well.
So what are our future plans? Well, in the future, we hope to release your app on the Google Play Store and the iOS App Store. And we also believe that AI is a really useful tool for early detection of medical conditions, thus allowing a more affordable healthcare in like the US.
So what group is the app for? The app is for people who are over the age of 65 or high skin cancer risk, people who are living in poverty who might not have access to dermatologists, as well as people who are unable or afraid to attend doctor's appointments frequently. And finally, we wanted it to be accessible to people who want to check their skin frequently or maybe are overly worried about hypercontracts.
So you may be wondering, what makes your app unique? Well, the only other competitor is the mole checker skin dermatology can just lock behind a paywall, really limiting the accessibility for low-income users. In addition to that, it only checks for one type of skin cancer, melanoma, while ours actually checks up to 9 skin diseases.
In addition to that, one big thing about skin cancer like detection models is that the problem is they're really unfair across skin tones, and it's really hard to detect it for certain skin tones. We decided to mitigate that as much as possible by using Gaussian white noise and generative networks to actually augment our data set and make it bigger so that our model gets out to be more fair across all types of skin tones. So what did we actually learn? As a project manager, I had to really focus on deadlines and meeting them and then working between all 5 of us as we were really busy between extracurriculars, jobs, and school.
As the designer there, I learned how to make an art design come together with the computer and to make it aesthetically pleasing as well as have form and function.
As a lead coder, I gained a lot of experience using React Navigation and other React libraries, and also Expo. And I also gained experience training machine learning models, which can be beneficial for other projects I work on in the future.
So if there's one thing that you learned from our presentation, I want you to know that early detection is crucial. If you know anyone with any type of history of this, please refer them to our app or a medical professional.
Thank you for the opportunity. Let's start the question round now.
Judges, your questions for our team.
Yeah, so what's the learning module? You guys kind of explained already the relationship, but I guess what difficulties did you find in that learning module, and what are the others that you guys tried out?
You mean a technical difficulty, like programming? So that one's really cool. So there were 2 ways to use the model. We could have either deploy it on the cloud and use REST APIs to call the model within our application. But that would require the use of the internet, and we wanted to make our application more accessible to people with maybe lower internet access. So our challenge was to actually put the model inside the app, and so it doesn't have to use the internet. The main issue with that was compatibility, because loading the model actually required libraries that were not compatible with the current Expo library that we were using. And so how I took care of that was main problem was actually bundling the model.json and wait.bin file, and the bundler was not compatible with the library, so I had to write my own JavaScript bundler and other functions that also take care of processing the raw image data and overall creating a model instance that can be used to make predictions.
Yeah, adding on to that a little bit, like another thing that I kind of touched on was like making it more fair across different skin tones. So I'm actually working on a research project right now that's like making a model that's more fair across different types of skin tones. And so that was another thing that we really wanted to make sure we did. And that was another thing that was like really hard, and probably one of our hardest for us to do.
Could you talk a little bit more about that, how you trained the model?
Yeah, so first thing we needed to do was like augment our data set, right? And so we used white noise, which had been produced together before, but then on top of that, we used generative network, which I actually like component generative network and then added images, tested out like from like 1 to 500, 100 to 500, see how that impacted. And on top of that, the second thing we did was like knowledge distillation. So we used two models. It was like SwinNet and then I forgot the name of the other model, but we basically like combined those two models through like knowledge distillation, and then we created the model through that.
I've seen some really intentional work and thought on the user design and the design overall. And I see credits here. Are those all free resources?
Yes, all the credits are free resources, especially flat icons, side code, and free things. They're all free.
Really nice and very resourceful of you. I wonder if you have thought about in your future plans. So you're trying to get to the low-income community that may or may not have access to healthcare easily. So they've detected something. Do they know where to go for help, etc.?
Yeah, so actually in our information slide, our information page in our app, right below that is just a couple links. The first one is a international dermatologist lookup. So you can go immediately to put your zip code in, and it will just have literally the closest place that you can go to a dermatologist. Obviously, our app is supposed to be that first step, and so we want to make it to that next step to the dermatologist.
So I know y'all mentioned next steps being deploying to Passport or Google Play. Are all the photos only stored on device? Are they sent to cloud at all? Or is it all? No. Okay. Have y'all thought anything about, because this would fall under like a HIPAA certification, especially if you were doing any additional collection of information and identifying parameters. Have you thought about that at all?
Yeah, no, this really like doesn't, like having that we don't use the internet connection, we don't store it anywhere other than like on the phone. Like, so I think like we'll be fine under those. We definitely don't want to like get any problems on that. And so yeah, we just don't store anything, don't like, yeah, Kumar could probably talk about it.
I think maybe we could, instead of storing images, or like the images could stay on the phone, I think maybe something we could do is basically record like where skin cancer is currently spreading across the world, maybe like record that data just for like information, reason, yeah.
We've got about 1 minute left. Any other questions? Well, thank you.